Hola, blog. Okay, so today I'm doing a video about the rotation of a matrix. I know I had done one. The one that I did created an extra array, and filled it in that way. But today I'm doing the in-place version because I'm not gonna be lazy. But the in-place version, it's not that as hard as I thought it would be. When you get used to seeing this stuff. So yeah, I checked it today and I was like, oh, okay, I think I could do a video on this. It's very simple, it's very straightforward and fast. And I know there's people who no comment. But some people, they just do those one-line code and I just don't understand. I'm just like, no, I don't understand. So I'm going to do a breakdown. Hopefully you guys will understand it, and I'm going to do the breakdown in the blog also. So let me know if you have any questions, and yeah, let's get started. Okay, so we're back. So as you can see here, we have, oops, where's my pen? Okay, we have our original matrix, okay? Our matrix is basically a nested array. As you can see, there's 3 values in it, and for this problem, it has to be an n by n. So as you can see, there's 3 rows, and there's also 3 columns. So make sure you have an array. You can't have an array, a matrix with like 3 rows and then like 4 values in each, or 4 columns. So what we're going to turn this original array into is a rotated array. We're rotating by 90 degrees. So basically we are moving this 90 degrees. So it's that way. I think this is clockwise. Yeah. So at the end, it should look like this. You see 1, 2, 3 moved over here. So that's clockwise this way. So that's the end result. All right, so let's get started. Okay, so first we start with defining our function. So we'll just define this by rotate. Yes. And we're going to give it a matrix. You can call this whatever you want. And basically the matrix will be equal to this. So this is what we're starting out with. All right, and then the first thing that we're going to do is that we're going to reverse this matrix. That's the first step. So when I say we're going to reverse, that means we're going to move 7 to the top. In the beginning, this is index 0, this is index 1, this is index 2. And then we reverse, this is going to be index 0, this will be index 1, this will be index 2. So as you can see, this was what the reversed result looks like. So how we're going to do that, there's 2 ways to do that. We can either do matrix.reverse, which is a built-in Python function, or we can do, it's pretty much up to you. Or we can do this version, which is matrix equals matrix dash, well, what do you call this? Colon, -1. That's basically the typical way that you can easily reverse anything in Python. Or you can do, should I show you both of it? I'm going to comment out. So if this was real code, this would be a comment. Matrix dot reverse. And they will do the same exact thing. So I had to switch my paper over because I made a mistake, but as you can see, here is the reversed version over here still, which we reversed the original. Before it was 1, 2, 3 was at the top, and then 4, 5, 6 was in the middle, and then 7, 8, 9 was at the bottom. So anyway, so now we're going to do the for loop. So the for loop is supposed to grab for I in range length of the matrix. So our matrix length is 3 because we have 1, 2, 3. So we're counting the rows. 1 row, 2 row, 3 rows. So I will be at 3, the length. And then to grab the columns, we're going to do for j in range I. So our range of I is 3, so j is going to go up to I. So j is basically the columns. Boop, boop, boop. So hypothetically, if we are in row I, J will be the value, 7, 8, 9. You feel me? So, all right, so now we're going to do the swap. All right, so I know matrix questions, they can be so confusing, but I really want you guys to understand this. So normally when people reverse a matrix, what they're doing is they're flipping it and then they are transposing it. So when you transpose, you're flipping on the diagonal. So you're switching the values. We're going to switch 7 to 3. So if I go back around to the original paper, right? This is our original matrix. What do you notice about the difference between these two? If you were doing this counterclockwise, our first row would become our first column. But in the rotated clockwise direction, our first row becomes our last column. So as you can see, if you look this way, do you not see that like these were all rows? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we literally flipped the whole thing over. So all of these rows became columns like these. Okay? So which is why when you see this case, when you see the reversed version, if you look between these, you can start to see where things were happening. So here's the reversed version of our original matrix. We began to switch. You can see we switched 1 and 9 here. Oops. We switched 1 and 9 here, and now 9 is over here. 1 is over here and 9 is over here. So that's what we're going to be doing. We're going to be switching our values across. We're going to be swapping them. You can see here, we switched 4 and 8. 5 stays in the middle. We switched 3 and 7. Okay? So hopefully you guys understand that. That's what transposing does. I'll include a video to Khan Academy that helps me understand how to transpose a matrix if you guys are still confused. So we're basically switching our rows to columns. So we're going to start with the swap. Okay, and first we're going to do matrix I, J, and we have to do a simultaneous swap to change the values at the same time. Matrix J, I, and it's going to equal matrix J, I, and matrix I, J. Clearly I ran out of space, but basically matrix IJ will swap with matrix JI, and matrix JI will swap with matrix IJ. So we start with our first iteration for 0 in range, the length of the matrix, and then we go in and we do for j in range of I, but range of I is 0, so we can't really go anywhere. So then it goes again, and I turns into for 1 in range, the length of the matrix, and finally, now that I is 1, j can be 0. So now what we're going to do is that now that for j in range I is 0, we can start swapping. So here we have I will be 1 and j will be 0. So we're swapping these values. This is column 1. So remember we start 0, 1, 2. Those are indices. Row 1, this is row 1, and then column 0, and that's value 4. So we're going to swap that with, as you can see right here, j. So we're going to swap that with ji. Okay, so j equals 0 on this iteration, and I equals 1. So we're going to swap it with 8. So as you can see, we swap the second row for first column with the first column second row, okay? If that makes sense. So here you can see we swapped 8 and 4. And then we're going to keep on doing that. So we're going to swap these two. Okay, so listen to this. You're going to keep on telling yourself in your head. So you're going to swap the first row with the second column and the second row with the first column. Okay, so we did that here. And then after that, we're going to increment again. So now that we've reached the end of this, I goes to 2. So now I, for 2 in range, the length of the matrix, now we restart again. So now we're going to be here, and this is index 2, and J will start at 0. So we're going to be at index 2, column 1. So we're going to swap this value right here. So right now we are at 2, 0. So 2, 0 is 1. We're swapping that with JI. So J is 0 right here, and we're swapping that with the second. 0, 1, 2. So we're flipping 9 and 1, okay? 9 and 1 flipped. And we're just going to keep on doing that over and over. And finally, we're going to arrive here. So when you think about it, think of this one more time, okay? So here we are swapping the first row, last column with the last row, first column. First row, last column, last row, first column. And then when we swap anything else, it would always be the opposite.